312 BC, Rome. The censor Appius Claudius Caecus orders a new road south toward Capua. It needs to move Roman soldiers faster through a war zone. Workers begin cutting a line across the landscape. More than 2,000 years later, parts of that line are still there. This is how the Romans built roads that refuse to disappear. The road becomes the Via Appia. Later generations will call it the Queen of Roads. At first, its purpose is practical. Rome is fighting the Samnites in southern Italy. Armies need food, weapons, messages, horses, and reinforcements. A muddy track that disappears after heavy rain is not good enough. So the Romans do something expensive. They engineer the ground itself. The first problem is the route. Roman roads are famous for appearing almost unnaturally straight. That does not mean engineers simply drew a line and ignored everything in front of them. Mountains, rivers, unstable soil, and steep slopes could force changes. But where the terrain allowed it, surveyors aimed for direct routes. Every extra mile costs time. Once the route is established, workers prepare the roadbed. And this is where the popular image of a Roman road becomes slightly misleading. There was no single universal recipe. Not every road contained exactly 4 perfectly named layers. Not every road was paved with giant stones. Construction depended on local geology, traffic, importance, and what material could be obtained nearby. But major roads could be built on an extraordinary foundation. Archaeological work on the Via Appia has identified a trench containing roughly a meter of earth and gravel. Above it sat a thinner layer of gravel and crushed limestone. Over that came the surface stones. On parts of the Appia, those stones were basalt, large blocks of hard volcanic rock. The visible road was only the final layer. Most of the structure was underground. That mattered because a road surface does not normally fail from the top first. Water enters gaps. Soil underneath softens. Wheels push the surface downward. Small depressions collect more water. The depression becomes a hole. The Romans could not stop rain, so they tried to move it somewhere else. Many Roman roads were raised above the surrounding ground on an embankment called an aga. The carriageway could be slightly cambered, higher near the center and lower toward the edges. Ditches along the sides carried water away. It sounds simple. It is also one of the reasons the system worked. A perfectly strong stone placed over wet, unstable soil will eventually move. A less impressive surface over a well-drained foundation can last far longer. The Romans were not making indestructible pavement. They were controlling water. Then came the surface. On a major paved road, stones were selected and fitted tightly together. The top could be shaped into a hard-running surface capable of carrying people, carts, animals, and military traffic. The Via Appia itself was about 1 meters wide along its main carriageway, enough for traffic moving in both directions, with pedestrian areas beside it in some sections. But across the empire, roads looked different. In Britain, many were surfaced with gravel or crushed stone rather than monumental paving. Archaeologists find raised roadbeds, multiple layers, side ditches, curbs, culverts, and quarry pits. In some places, the builders cut into hills. In others, they raised causeways across lower ground. They used what the landscape gave them: stone from one region, gravel from another, sand where it helped. Material excavated from the roadside could even become part of the road itself. This made the network repeatable. Rome did not need to ship Italian paving stones across an empire. It needed engineers who understood the same problems: find a stable route, build a foundation, raise the road when necessary, drain the water, compact the surface, repair what breaks. That last part is easy to forget. Roman roads were not built once and magically left untouched for 2,000 years. They required maintenance. Archaeologists in northern England have even found evidence of Roman-era pothole repairs. Roads were infrastructure, and infrastructure wears out. Wheels damage surfaces. Floods undermine foundations. Sediment fills ditches. Stones shift. Rome had officials responsible for important routes. Repairs continued because the roads were economically and militarily valuable. This changes the question. The mystery is not why one construction crew discovered a secret formula for eternal roads. They did not. The real achievement was that Rome created a system worth maintaining. The Via Appia connected Rome first with Capua and was later extended toward Brindisi on the Adriatic coast. Roads like it linked cities, ports, forts, markets, and provincial centers. Soldiers could move through them, but so could merchants, officials, letters, taxes, travelers, and ideas. A road built for war slowly becomes something larger. The empire begins to organize itself around the network. Settlements grow near routes. Inns and stopping stations serve travelers. Tombs line the approaches to cities. Existing paths are absorbed. New junctions become important simply because the road passes through them. And once that happens, destroying the road becomes inconvenient. Even after Roman political control disappears, the useful route is still useful. Medieval travelers follow parts of it. Later roads reuse its alignment. Farmers cross it. Cities expand around it. Modern highways sometimes run surprisingly close to corridors chosen by Roman engineers centuries earlier. The road survives because the landscape remembers it. But even the Via Appia did not remain frozen in 312 BC. It was extended, resurfaced, repaired, altered, buried, uncovered, and reused. Its famous stone pavement was introduced gradually. What survives today is the result of construction followed by centuries of intervention. In the 6th century AD, long after the road had first been laid out, the historian Procopius was still impressed by the condition of its paving. By then, the original builders had been dead for roughly 800 years. Their road was still carrying people, and that may be the most important part of Roman engineering. They did not need concrete trucks, asphalt plants, lasers, or modern earth-moving machinery. They needed stone, labor, drainage, surveying, organization, and enough experience to understand where roads usually failed. The famous paving stones get the photographs. The invisible foundation did most of the work. Today, sections of Roman roads still emerge from fields, woodland, cities, and beneath later highways. Some survive as stone pavement. Others survive only as raised strips of earth detectable from the air. In Britain, laser scanning has revealed routes that had effectively vanished beneath forests for centuries. The surface can disappear, the line remains. And back outside Rome, the Via Appia still follows a decision made in 312 BC. Build south, toward Capua, and make the road strong enough for Rome to move quickly. The empire that ordered it is gone, the road is not, and beneath some modern routes, the Roman line may still be waiting. The Roman roads are easy to admire because the stones are still visible. But the more useful lesson is buried underneath them. Durability was not one brilliant material or one secret technique. It came from dealing with ordinary problems carefully. Water had to leave the road. Weak ground had to be strengthened. Local materials had to be used intelligently. And when something broke, somebody had to repair it. That sounds less impressive than an indestructible road. It is also more useful. We often look at old engineering and imagine that people in the past possessed some lost knowledge we no longer understand. Sometimes they did things differently. But in this case, much of the achievement came from consistency. Thousands of workers, engineers, officials, and communities kept applying practical solutions across enormous distances. And then they kept maintaining them. There is something quietly modern about that. Good infrastructure is rarely the result of one spectacular decision. It is usually the result of hundreds of boring decisions made correctly. Over and over again, the stones survived because the system around them worked. Maybe that is why a Roman road can still feel so strange today. We are looking at something built without modern machines, yet designed around a principle that has not changed much at all. Make failure harder before it happens.